Bismillahirrahmanirrahim. Welcome to this video tutorial in which I'm going to explain about the static NAT translation, dynamic NAT translation with overloading, that is port address translation, then default routing and static IP routing. So before we step into this configuration part, you have to understand about this topology. The ping network is 192.168.10.0/24. Here, this yellow has been connected to the Frankfurt router is 192.168.20.0, and in the Paris router there are two networks, internal networks, inside networks. One is 192.168.40.0 and this green 192.168.30.0. And this yellow here, this yellow is the network between the Paris router and the ISP provider. And the pink here at the right side top is a public network 200.210.0, which has one server and one PC, and both have public IP, and you can see the public IP there. And now this public IP 110 is given for this organization. This organization has many branches, and this public IP is 110.10.10.0/27. From this, okay, we have to pick some IP addresses for the NAT concept. Okay, static NATing, and also for the dynamic NAT concept. Okay, and also the connection between the ISP and the Paris router. Okay, we need it. So using that IP, okay, using this network address, I did a subnetting, and I got 4 subnets. So this one, let's say A, I can use for the connection between the Paris and the ISP /30. This /30. So the network address is 110.10.10.24. That means starting IP is 25 and last usable IP is 26, and this is a broadcast IP in this network. Okay, and I have 3 other subnet from this network address, so which I can use for static NAT, dynamic NAT, and for any other purpose in the future. So now, when all these systems like PC2, PC0, PC1, okay, when all these systems they access the server 4, which is in the public network, whose IP is 200.210.30. This is a public network. You know that these systems they have private IP, and if they want to access connect with any system in the public network, then their private IP address has to be replaced with public IP address in the public network. So that functionality would be done by the NAT, network address translation, in this router. So this is a router which connects the Frankfurt, London, okay, and the Paris with ISP. So we will configure the network address translation here. We will configure the network address translation here. 2 types of network address translation. One is PAT, port address translation, for all the PCs. Okay, when they access some external servers, external services if they access, okay, they need a public IP address. So we would configure the port address translation for them. And second scenario is like this. This organization, okay, in the Paris branch, they have some server. In that, they run some web application. So they run some web applications. You can see it is on. So this PC4, which is in the public network, if you try to access this web application in this server, it would be using some public IP address, not private IP address. So this system has a private IP address of 192.168.40.10, but this will not be used by the PC4. The PC4 would use some public IP address to access this web applications. So when the PC4 or any system in the public network uses, they want to connect with this web application, um, okay, they will just use a public IP. And when that request packet come to this router, Paris router, that would be translated into the respective private IP address. Okay, so this will be done by the static NAT. So these are the first two objectives. One is port address translation, and second one is static NATing. And the third objective of this lab is uh, I have so many routers are there. So I have configured the OSPF in each and every router. So you can see show run command and check. I have added the network. For example, this router I added the 192.168.10.0 and 10.10.0. And here in this router, I have added the 192.168.10.0 and 10.10.4. Okay, so this WAN I have used the 10.10.0 and I did the subnetting and I have configured the IP address. So you have to configure the OSPF in all the routers. But when you come to the this router, let's say Paris router, okay, you should not include this public IP address in the OSPF. So this you should not use in the dynamic routing. Instead, you have to go for default route option. So that is what I am going to explain. So I have configured all the IP address for the systems, and then I have configured already the OSPF for this London router, Frankfurt router, and I have configured the routing IP address for the WAN router, and then I have configured the IP address for the server. Here I have configured the IP for the PC1. Then I have configured the IP address for the external server. Here I have configured the IP address here already. Then I have configured the IP address for the ISP. So now our focus is just four things: static NAT for this server. Okay, we have only one server in this organization. For that, we want to configure static NAT. Okay, if I have one more server, then I need two public IP. But now I have only one server, so I need one public IP. So first static NATing, and all these PCs they have to communicate with the external network. Okay, so for that they need public IP. So I will assign one public IP, only one public IP. Okay, for all the systems from the Frankfurt, from the London, from the Paris. Okay, to connect with the external network. Okay, third one is I'm going to show how to configure the default route, and then I will show you how to configure the static route in the ISP so that any traffic to this network, okay, this 110.10.10.0, any traffic to this network is forwarded to this Paris router. Clear? So we will begin the configuration. So first I'm going to configure the static, uh, sorry, I'm going to configure the default route. So I go to the CLI. Before I go into the default route, let me configure the OSPF. So I go to config T, okay, then so I create OSPF. So router OSPF 10. Already I have created the OSPF with process ID 10 in other routers. Then network. So let me add this network first. 192.168.168.30.0 is then 0.0.0 255. That's a wildcard mask. Area 0. Then let me add this blue network 191.168.40.0.0.0.255 area 0. So we have added the two networks already connected to this Paris router. So So now this one more network. This is connecting the WAN with the Paris router. So network 10.10.10.8 and wildcard mask is 0.0.0.3 area 0. So we have added all the networks which are connected to the Paris, but you can see that I didn't add this network, this yellow, which is connecting the Paris with ISP. Okay, so this is what very important thing you have to keep in your mind. So please don't add this network. Okay, so how we uh, handle that using default route. So I will show that. What you have to do is after that you just exit. Then let me show you how you configure the default route. So IP route 0.0.0.0. Then the wildcard mask is 0.0.0. Okay. So the first one is 0 IP address, second one is wildcard mask 0. So it means for any network, okay, you have to, we are going to say any network, please forward the traffic to the uh, interface that connects the Paris with the ISP. So let me check which interface is that. So you can see SE3, SE, SE2/0. You can see the IP 110.10.25. Okay. So the interface is SE2/0. Alhamdulillah. So you have to put the interface SE2/0. So please try to understand IP route 0.0.0.0.0 wildcard mask. We are saying any traffic should be forwarded through this interface SE2/0, which is connecting Paris router with the ISP. Then You have to go router OSPF, then you have to say the router OSPF, then and then you have to say default default question mark default information. Okay, so question mark. Okay, originate. So default information originate. So when you give this command, what happens? This information, the default route information, will be forwarded to the WAN router, to the London router, and as well as to the Frankfurt router. So whenever they want to forward any traffic to the external network, they will automatically forward their packets to the Paris router. So this is default information. Okay, so now we have finished this stuff. Okay, next what I'm going to show you is how to configure the static NAT for this server. So please, you can note what is the public IP, sorry, private IP of this server. Private IP is 192.168.40.10, right? So when someone from outside they access this, okay, they have to use a public IP. Okay, so already I have done the subnet 10.110.10.0/27. I have created 4 subnet. One with size PC size 2, remaining 3 PC size 6. Okay, IP address 6. So now let me choose one of them. Okay, let's say I am choosing this subnet 10.1, 10.1 to 10.6. I am choosing this. Okay, so the wildcard mask is, I mean, the subnet mask is this, and the seeder value is this. So this is the first usable IP, and this is the last usable IP, and this is a broadcast. So I choose the first subnet, and this subnet, the A subnet, which is identified using the identifier A, I use to configure the IP address between the Paris and the ISP. So you can see here Paris, okay, Paris router AC2/0, which is connecting with the ISP. You can see what is IP 110.10.10.25. How I got this IP? Because the public IP which I got from the ISP provider with /27, the major network address. I did the subnetting. Understand? So I choose from this subnet, I choose the .25 for the Paris, and then for this, okay, 110.10.10.26. Okay. So I have chosen the last subnet with seeder value 30, and from this I took one IP for the Paris router and one for the ISP router. So now let me configure the static NAT. Exit here. So this is the command IP NAT inside, IP NAT inside source. So source, what is the IP of the server? Okay, static is, and the IP of the server is 192.168. Okay, then it's 40.10. Okay, and what about the public IP now? So this is inside local. Inside local means the IP address of the system, the private IP of the local system. So now what is the public IP of the local system that you are going to assign? That is going to be global, inside global. So already I told you we did the subnet, and we have these range of IP addresses. So I let me choose 110.10.10.1, okay, for this system. So this is a private IP address of the server 192.168.40.10, and this is the public IP address which we did subnetting already. I have shown you. Okay, so in that subnet, the first subnet I took, in that I take the first IP and I assign to the server. So this IP is called inside local private IP, and this one, the public IP, what you assign through the static NAT to the server is called inside global. Then that's correct. Okay, so now we have to identify, okay, which interface is inside, which interface is okay. So basically, FA1/0 in the Paris router is inside, and SE3/0 is inside, FA0/0 also inside, and SE2/0 is outside. Okay, so let us do this configuration. Let me go to interface FA1/0 IP NAT inside. And then let me go to interface FA0/0 IP NAT inside. Interface SE3/0 IP NAT inside. And interface SE2/0, which is connecting with the ISP, okay, IP NAT outside. So now we have done with the static NAT configuration. Next, we have to configure the PAT, port address translation. Okay. Why we need port address translation, guys? Because there are many PCs in this network. Okay, so when they want to connect with the external network, public network, when they want to forward the packets to the external network, then they need public IP address, which is okay. However, they are configured with a private IP address. So when all these packets reach the Paris router, we are going to map the private IP with public IP using dynamic NAT with overloading, okay, or we can call it as port address translation. So let me go and show you the configuration. Exit. First step, you have to create a pool, okay, IP NAT pool. Okay, let us give a pool name as Oli. Let's give a pool name as Oli, and then pool name as Poly, and then you have to say how many public IP addresses are you going to allocate to this pool. So we have already done the subnetting, and we have, like in the first subnet, the IP public IP addresses 110.10.10.1 to 6, and in that already we have allocated 10.1 to this server. Suppose we have one more server, then we would have given 10.2 to that server. Am I clear? So 10.1 is already utilized. So I am going to, let us assume the company might use one more server also, or two more server in the future. So what I am going to do, let's say one more server the company might use. So I am going to choose 110.10.10.3. Let me start from 4. Clear. So I am choosing this public IP address from the subnet. Under 10.1, 10.2, 10.3, let me allocate to the static NAT. Okay, assuming that the company would scale up and in future they might add one more or two servers. Okay, so now let's say in this pool, do you want to put one IP or two IP? Let's say 110, 10, 10.4. So this first one is called starting IP, starting range. This one is the ending range. Suppose you are going to put only one public IP in this pool, then the starting range and the ending range will be same. Okay, and starting and ending IP address will be same. But let's say I want to put two IP address. So I'll the starting is 4 and the ending is 5. Okay, so it's up to you. You can put one or two or three or four depending on the number of public IP addresses available. But even with one, you can perform the port address translation. So after that, what is a subnet mask for this network address? The subnet mask is 255. Don't make any mistake in the subnet mask. Be careful thoroughly. You have to check in each and every instance of the configuration, okay, whether the subnet mask is correct or not. So this is 248. Okay, so IP NAT pool. Okay, so what is a mistake? That's good actually, because when some mistake happens, it's good for us to learn from that. The mistake is I forgot a keyword net mask. Okay, so now the we have executed this uh, dynamic NAT with co-loading command. So we have created the first step. We have created a pool. Okay, in that pool we have put two public IP addresses, 10.4 and 10.5. Okay, and also we have declared the net mask. Second command is we have to create a access list. Very important. Okay, so what is the access list? Um, See, you want the dynamic NAT with overloading for which network? Which private IP address? You have here 20 network, you have 10 network, you have 30 network, you have 40 network. So you have one, two, three, four networks, right? So all the four networks, for all the networks, four networks, do you want to provide the NAT translation or you want to provide to the specific network? You want to provide only to the yellow or you want to provide to the yellow and pink? That you have to decide using the access list. Okay, so let me create the access list. IP, sorry, access list. Let's say access list number is 10. It means you can understand it's a standard access list. Permit. So I say permit 192.168.20.0. The wildcard mask is 0.0.0.0.255. Then I say access list, then permit 192.168.10.0.0.0.255. Then I say access list, then permit. Okay, so 192.168.30.0. Wildcard mask is this. Then access list, then permit 192.168.0.0.0.255. So the first step in the dynamic NAT is you have to create the pool, which I have explained. Okay, then we have already done with that. Then the second step is you have to create the access list and you have to permit the networks, okay, that are allowed for the network address translation. So second step also has been over. And third one, you have to identify which network, which interfaces are inside and which network are outside. So FA1 slash 0 is inside, FA0 slash 0 is inside, okay, SE3 slash 0 is inside, and SE2 slash 0 is outside. And already we have done with while we were configuring the static NAT. Okay, in case you haven't done that, you have to do now. Okay, let me repeat again. You have to identify the interfaces as inside and outside. Already we have done this configuration, so I'm not going to repeat that. Hope it's clear to you. So first we created the what we done. We created the pool, then we created the access list, then we declared these interfaces as NAT inside or outside. Okay, then the fourth step is we have to map the pool with the access list. That's the fourth command, fourth step. So this is the command. You have to be in the config mode, IP, okay, NAT inside source. Here we are not going to use the static keyword because it is not a single source system, but it's going to be list. And the list number already we have created the access list. And what's the number we gave to the access list? It's 10, right? 10. So source list 10. And what's the name of the pool? The name of the pool is Poly. Yeah. The name of the pool is Poly. And very important, finally, if you forget this, what happens? The dynamic NAT will be executed. The dynamic NAT has disadvantages. It will map one public IP to one private IP. So we have two public IP in the pool. So two PCs can use that two public IP. When the third system try to access the public network, it has to wait in the queue until it gets the public IP address from the other two systems. So it has some disadvantages. So we go to the third technique that's called overloading, or we can call it as port address translation. So we have to add this overload concept where the each and every systems in the inside network, when they access the public network, they are identified using the port numbers, not only their private IP address, but also using port address. They are distinguished. Okay, so IP NAT inside source, this 10 2 is poly and overload. So now this dynamic NAT configuration is done. So now next step is going to be this. What's the next step is we have to configure the static route. Okay, so static route. Okay, so let's go into this static routing, so which we have to do it in the ISP here. Okay. So this is a public network address 110.10.0 slash 27. So let's find what is the. Just find slash 21 subnet mask. So 224 is a subnet mask. Okay, so we'll go to the quick T. So we are in the ISP now. Okay, so we are configuring the static route. Why? Because see, from outside, someone, for example, from the server or from this PC4, sorry, from the PC4, someone is trying to access this server. To access the server, already we have given that 110.10.10.1 as the public IP. So this PC4 knows the public IP of this server through which it would access this web application. So when any packet come to this router, and in that packet, let's say the the remote IP address is 110.10.10.1, so it should know where to forward this packet. So we are going to say that any packet within this network range, please forward to the through this interface. And so when it forward through this interface SE3/0, it would automatically reach this router Paris. Okay, so that's what we are going to do. Okay, so the command is IP route, okay, 110 dot 10 dot 10 dot 0. Okay, so 255, 255, 255, 24, sorry, 224. Okay, so it should be forwarded to which interface? SE3/0. So SE3/0. So this static routing is finished, and we will go and write, okay, reload the stuff here. Let's go here and write, okay, reload. So now let's students, let's try to ping from here. Yes, successful, and from here to here, successful. and from here to here it's successful. Okay, and so let's say from here, let us access this web application here. All this 200.200.10.3. Yeah, Alhamdulillah, we were able to access this web application from the private network. Okay, then let's say from outside, let us try to access this web application. I think this IP is 14.10, yeah. But we shouldn't use the private IP. We have to use the public IP. Um, so the public IP what we have assigned is 110.10.10.1. Bismillah. Yes, Alhamdulillah. So after that, these stuffs. Okay, so enable. Okay, then show NAT. Show. We can do this command show IP NAT translation. So you can see whatever translation has taken place. So you can see what is the inside local, what is the inside global. Okay. So inside local means, let me repeat, whatever the private IP address of the system in the inside network, and the public IP what you are going to map to these systems is inside global, and the outside, these are outside local and outside global. So that's all I have for this video tutorial. So please quickly I give you a quick recap. So in this video tutorial we have discussed mainly about the dynamic NAT, static NAT, then default route and ISP static route. And one more thing, like suppose let's say this ping network. Okay, you should not allow the ping network to access the internet. So, okay, then what you have to do is you have to create a extended access list in this Paris, and you have to deny the traffic, okay, to any outside, and you have to apply this access list to the SE2/0 interface. Okay, so that's all I have. Okay, thank you very much.